Good afternoon, everyone. It's Mark Dye, Associate Editor of Vanilla Plus here. Hope you're well. Good afternoon and welcome to another in the Thought Leadership webinar series brought to you on behalf of Vanilla Plus, Europe's leading brand driving profits for communication service providers. As you know, we're uniquely positioned to report on the massive changes impacting upon the communications space. And since our launch in 1999, we've tracked and reported on these changes and changes setting the agenda for the industry. So we're now in our 13th year of publishing and standing in pole position across the EMEA to inform and provide insight into this dynamic market through multiple media channels. Of course, the CSP revolution is actually affecting us all, and our focus on profitable operations makes Vanilla Plus the perfect guide and reference source for you all. So today we're delighted to introduce Ian Dawson, Senior Marketing Manager at Nexus Telecom, who's going to be talking about iCDR, the next revolution in service monitoring. But first, let me introduce you to Dan Baker, Research Director of the Technology Research Institute, and he'll explain the traditional approach to service monitoring and how Nexus is evolving on that.
Hello, hi. Thank you, Mark. 3 weeks ago, in another Vanilla Plus webinar featuring Nexus Telecom, we discussed the topic of turning the telecom business into a real-time machine. And I talked about how Apple, the maker of iPhone and the iPad, and now the second highest valued corporation in the world after ExxonMobil, operates its business in real time because it gets very fast feedback on what's happening across its organization. Now, Apple's approach is much faster than the way most telecoms operate with their many fiefdoms, be they billing, marketing, operations, engineering, network, or all the database silos. And a telecom business is relatively slow and pondering because it was designed for batch processing. Many times you wait for a process to complete, such as a switch being pulled from mediation data, or you wait to get your hands on data supplied by another department. Okay, so how do we get these telecom fiefdoms to exchange information more quickly? Well, the secret, I think, is to wire your data for real time, and that's what Ian's presentation is all about. He's going to explain how Nexus Telecom has come up with a way to dramatically speed up the process of network troubleshooting and analysis. I'm sure you've heard of the notion of a smart grid in the utility industry, where the basic idea is the electric grid and consumer prices for electricity will flex up and down to respond to the demands of power at any particular moment. Well, this is exactly where telecoms need to go. We need to turn telecom operations into a smart grid. Now, the monitoring of service quality for IP services has been making progress over the past decade or so, but it's anything but a real-time process. And now, with the mobile internet growing, being able to analyze that data and the flows and services is much more important than ever. Are people getting the quality of service they are paying for? That's critical to know because with the network getting more and more complex, problems can quickly get out of hand. The first thing I'd like to show you is how the signaling data, SS7 and SIP, is traditionally gathered from the network to do troubleshooting. The diagram shows a simplified overlay of a network in Western Europe. Now, mirroring the network, you also have various signaling links, and probes are deployed at various points in the network, passively monitoring these links, and then stores the link in the information for every call and for other network events on a local hard disk. Okay, the traditional signaling approach is to send the full raw signaling data to a central server where the signaling links can be correlated when it comes time to troubleshoot the network. Now, the amount of signaling data and processing required to transport the data from the probes to the central server or to do distributed processing between probes is pretty substantial. So in many cases, the IP bandwidth being taken up by the traffic is heavy enough that it forces you to sometimes deploy regional services or more regional probes, which complicates the correlation of signaling links later on. So given the increased complexity of today's network, this traditional approach is not ideal. And the next few slides, I'm going to walk you through three major issues with this method. Okay, first of all, the biggest problem with the traditional approach is simply a delay in the meantime to repair network faults and performance problems. If you don't fix a major outage in a mobile switching center or a media gateway, it costs you money every minute. And if it's during the peak business hours, a significant delay is worth millions of euros in lost revenue and eventually customer churn. But it takes time to correlate signaling events. Using the traditional approach, you spend considerable time tracking down exactly where the records are located for troubleshooters to do their initial work. And the system either has to go back to all the probe storages or correlate the call link records in the central server itself that is associated, say, with a particular phone number at a particular time. It will typically take you 10 to 15 minutes to get the data you need to analyze one or two calls. Well, in any kind of debugging or troubleshooting situation like this, the ability of the system to quickly get answers to questions is invaluable. But waiting 10 to 15 minutes to get feedback on every query is costly and becomes unacceptable today. Now, there's a second issue as well. Whether you are periodically loading a central server with all the detailed call link records or having the probe servers exchange information back and forth across the network, it can be a significant burden on the IP network itself. How much of a cost is it? Well, IP capacity, of course, varies by country and operator. In countries like Germany, most operators have huge bandwidth IP networks, so there's relatively no impact in Germany. However, in poorer countries where there's little to no IP infrastructure, they need to conserve bandwidth as much as possible. At some operators, Nexus estimates the impact could be as much as 5 to 10% of the bandwidth. But even if it's only 1 or 2%, that could be a significant revenue loss during peak times of the day. And the last issue is reliance on high-level expertise. Because you have no index to quickly find a call or a data event, the old method requires having a highly trained network expert available who knows what databases to go to. Did the call from a mobile or fixed did it come from a mobile or fixed network? I mean, what protocols are involved? You need to know this information in order to get started to get the detailed call information. And then once you have the starting point, it takes quite a bit of time and processing power to correlate the call information on the fly. One vendor of SS7 systems like this does the correlation with probes. The probe that sees the call first is responsible for doing the correlation and contacting other probes in the network. Okay, now we're moving towards the 4G and LTE worlds. This crisis is getting fast. Mean time to repair or analyze the network, it's going to become much more critical. LTE, for example, because it does packet switching voice, will cause the amount of signaling to shoot up tremendously and will put the traditional burden to troubleshooting and root cause analysis even further behind. So to summarize, there are 3 issues with the traditional method of rolling up signaling data for analysis. Number 1, poor response time to get at the data, which translates to slower mean time to repair. 2, a burden is placed on the IP network. And 3, you need highly trained experts to get the correlation started. Now, Ian is going to show how Nexus gets around this problem. And the basic approach is to forward highly summarized call link records to the central server and then create an index of communication detail records, or CDRs, on that central server. And this index allows you to troubleshoot network problems in a matter of seconds, not minutes, because it uses the same principles as Google search. To understand how it works, consider 2 different approaches to recording what happens in a football match. Let's say one recorder is a sports writer who types what happens on the field in his laptop so he can write a story for tomorrow's newspaper. A second guy is a fan in the grandstands with a pencil and a small notebook. And every time a key event occurs on the field, he jots down a short description along with the game clock time. So he pencils in events such as second corner kick at 3:02, first goal at 15:45, second penalty kick at 35:17, and so forth. Okay, now let's say at the end of the match you want to review by videotape what happened at the second penalty kick. Well, that's going to be very easy for the fan in the grandstands because he can go to his notebook and do a quick scan on the second penalty kick, find the time of 35:17, and fast forward the videotape to review the action. So this illustrates the power of recording SS7 events as they occur and correlating that to a particular time, telephone number involved, and so forth. Now let's look at the sports writer. He's got a problem because he has created no index with his newspaper story. and that means he needs to do some intelligent guessing as to exactly where the second penalty occurred. He's forced to spend time finding the event because he doesn't have a direct reference to the starting point. So the sports writer's dilemma is similar to the traditional signaling, gathering, correlation approach. You struggle to get started and find out which switches are involved, what access points the call was started on, what protocols to go to. And that's very costly in terms of time to repair. It means you don't get the chance to do service assurance in real time. Another advantage of Nexus's new approach is that the CDR that's been captured from signaling is a more intelligent one because it's already correlated end-to-end customer experience across all technologies involved. So this is especially useful as a downstream data feed for enriching applications such as marketing, churn analysis, revenue assurance, billing verification, and fraud management. In addition, rather than wait for call detail information from a mediation system, data that's coming directly off the switch, you speed up the arrival through this signaling backdoor. And depending on the operator, of course, getting the mediation data might take you 30 minutes, an hour, maybe an hour of time, maybe take a whole day of time to get access. Okay, so my final slide here is, I think I've explained the basics of this new approach to service assurance, but to me, being able to troubleshoot and analyze network issues at search engine speed sounds like a very nice step forward. So now I'm going to pass the presentation off to Ian Dawson, who will delve into the subject in much greater depth. Ian?
Okay, thank you, Dan. So I'm from Nexus Telecom, and we have many products in this field of looking at network data and service data and customer data. And with this data, we can do customer experience management, service quality management, and protocol analysis. And a lot of the information, as Dan mentioned, is online. So what we're going to talk today is about one particular piece of information, and that's what they call the iCDR, because it's an intelligent CDR, and it's the next revolution in service monitoring. So we'll recap on webinar 1, and then I want to talk about the end-to-end service detail records, what was in the concepts and what's now, and we'll talk about online services monitoring data and how we can use these CDRs. So in our particular webinar 1, we had talked about data flow integration, and where we see the CEM, the customer experience management, and all the BSSF applications of the upstream, we're going to talk about the CDR coming from a monitoring system. With this data, we look at some of the uses where we can improve. And as Dan mentioned, we can improve the customer facing because now we have the information online. We can talk to the customer with the information right on the screen in front of us. That helps service assurance. We raise the expectation of the customer because we're getting a lot of information to the customer online, and he can see that we're really serious about our service assurance. We can also look at service level agreement fulfillment and make sure that services are delivered as we promised. And again, with revenue assurance, there's billing verification, marketing, resource management, and NOC troubleshooting, and many other applications. So let's look at the E2E data. We see the evolution of networks from the old telephone systems now to the modern mobile networks. And just like the evolution in networks, we have seen an evolution in signaling. So here we can see the GSM was 11 messages, GPRS is approximately 46 messages, and then we went to UMTS, we have 100 messages, and then we go to LTE, we have 200 plus messages. So the network evolution is we have increased service offering, and because of this complexity, we can offer a mobile internet, mobile banking, various business applications. Social networking is causing a huge headache to some operators, but it's a very good data sharing. Peer-to-peer, streaming applications, SIP and VoIP, and now we have the iCloud, which is a new service which is also going to cause a lot of problems in networks. So we have to get this information and find out what the customers are using and how they're using it. Now let's have a look at the IP networks this is an example here of a flow of a complete IP network where we see the UMTS talking to UMTS and just the complex protocols involved and the flow, and how this particular information is difficult to understand if we don't be able to see a diagram which is giving us an insight into what's happening very easily. If we had a diagram of, say, the 100 plus signalling elements incurring in this particular diagram, you wouldn't know where to look for the particular problem. So in our particular case, we have an iCDR which gives you the capability of looking at this particular call to find out exactly what happened and why it's failed. So let's have a look at a summary. So we're looking at service protocols in the signalling. They're getting more complex. And as we see the evolution of networks, the convergence, moving services into IP clouds, and the progressive focus of operators is moving from network to services and now to customer. And this also occurs when we have new technology rollouts. We have customers with our existing monitoring systems, and they don't like to have the monitoring system interfered with any way when they have a new network rollout coming on board, because they say to us they are blind because they don't see what's happening with the new services and how the new services are being introduced into the existing network and all the testing that goes on. So how can you monitor and capture this customer data? So let's look at the evolution of the concepts again. In the beginning, when we had mobile networks first starting up, we had a simple network where a mobile called another mobile, or a fixed net or whatever. To look at the particular problems involved and to help solve issues for customers, the first thing we did was we put protocol analyzers on the links. Now these protocol analyzers were put in particular sites and connected to the links, and they then were set up and started to record the data and made CDRs and had a CDR database on the site. And this information was either collected by staff going to the site or taken in lumps of data and transferred through the IP network. But this particular situation here is where the first CDR concept was born. It was called a call detailed record. But this is only because when we're looking at a protocol analyzer, the analyzer is looking only at a link. And when it's looking at a link, it sees a call going across the link, and so it's a call detailed record because you might have 2 or 3 protocols. Then what happened was the IP bandwidths, the ISDN system, started to expand, and the operators deployed data networks. And the idea was then, well, let's get all these CDRs from the sites and put them across an IP network into a central site, and then we have a central CDR database. So the CDRs were just transferred from the site to the central CDR database, and there the operators, or the NOC operators, the engineers, could have a look at the CDRs and drill down and find out what was happening in the particular network to solve issues. Then our mobile networks took another evolution. They become more complex, and therefore also more subscribers, and therefore the IP bandwidth expanded. The same concept was left with protocol analyzers on site, so the box never changed. The CDR database in the central site never changed, just the IP bandwidth exploded out a little bit, and the CDRs were left there. So this is the concept that's really stuck in people's heads, and we'll see what happens next when we go to today's network, where we have the iPhone Series 4. The IP bandwidth is immense, and it will get bigger. And we still have a lot of customers, or a lot of competitors' products still have the protocol analyzer idea stuck on a link and transferring everything to the CDR database in the middle. Now, Nexus realized when they started this was going to happen. So we designed a system that would not only survive the initial stages and provide a huge benefit to our customers, but would survive also evolutions, and we have proved that today. So what we have a communication data record. Because now we don't just have a CDR on a link, we have a call that goes across an entire network. And we want to know how the call went from A to B. And so what we call now a call, or CLR, is a call leg record, and it's a leg of the call between one particular part of the network to the other. And we can see as the call progresses through a network, we can see each leg of a call. Now, as you can see, the blue thin lines, we are making a record of this call leg, and we're sending that record to the central database. And in that central database, while the call is in progress, we're using the time to correlate these legs together and making a CDR. Now, our CDR, as we call a communication data record, is more intelligent because now we have a CDR on the top. It's got a summary of the call. It has the A number, the B number, the time of the call, duration, and some of the important information for a particular call. Was it a good call, bad call, and the performance and the cause values. But onto that particular CDR, we have all the link records. And in these link records, these contain fields of unchanged from the signaling. And they're correlated together and stored in the iCDR database. So at this stage, I would like to then go to some questions that we'd like to put to you. I'll hand over to Mark.
Hi guys. So thanks for that, Ian. Just before we go on, we've got a few online polls we'd like to go through. So basically this is your opportunity to take part and let us know what you think's happening out there. So in front of you now you should see poll number 1. So for you, how are most service problems detected in networks? Is that KPI analysis, customer complaints, service testing, GSM UMTS signaling monitoring systems, mobile internet monitoring system, or do you not want to vote? So if you could just press your votes now. Okay. So from that we can see the highest ranking one there is customer complaints. Yes, customer complaints. There's more than half of you think that customer complaints is the main, nearly 3/4 of you. Okay, so on to the next one. So in terms of service problem investigation, where do you begin? Is that alarm drill down, service CDR search, customer CDR search, network elements KPI analysis, or protocol analysis on a link? So you could let us know by registering your votes now, that would be great. Okay. You can see from that one, actually, that it's alarm drill down, where you guys start the most. And just remember, I just wanted to just point out with you for going forward just throughout this, that you can actually ask Ian some questions later on yourselves. So don't forget to be entering those at the bottom of your pane as we go forward. I'm just going to hand back to Ian now.
Okay, so it was interesting to see that the customer complaints was a particular interest, or is the most way where people see problems in the network coming from. And this confirms what we actually thought as well. Talking to our customers, we got different ideas from them, but the customer complaints was always coming up as one of the areas where we actually concentrated on. So when we look at customer service monitoring, the iCDR must contain a customer service protocol signaling transaction permanently correlated end to end. And this is where our definition of our customer data records, we have made this particular software to do this correlation while the call is in progress. And now we can see that the time to repair is a lot reduced, because when we are now searching the CDR database, we have the customer end-to-end record, and then we just find this customer complaint when he rings in by just putting the customer number in or any other details that he's got. Maybe we put the time, he mentioned it, and then push the search. And then we have the records in the window, and it's very quick. So the problem resolution can be faster, and therefore we decrease the potential loss of revenues. So the iCDR technology pays for itself. We don't have to convince our customers any longer. Once they've installed and deployed our particular product and concept, this is so. So when we have a look at our customer service reports, we put, as I mentioned before, we've put the customer number in and we get a list of calls. And these calls, as you see, there's one call there being selected in the brown line. When we click on that particular call, we get a view of the legs of the call. And there the legs can come up, all the legs of the call has been correlated where it's crossed the network. So this is a lot of information. It's an end-to-end information, and we can see the type of call, what was involved in the call, and maybe we can see there at the top whether the call was okay or not. Then we go down to a particular next step. We can actually say, okay, I want to view the call flow of this particular call, and then we can see how the flow went across the network. We can see in the different colours here the different protocols, and each line represents a particular network element. These network elements are displayed on the screen, but not shown here. We can also click between the simplified arrows, or we can actually introduce the name of the particular protocol process in each arrow. So the customer can see a very simple event-orientated call flow, and it's not a complicated 150-line investigation there where it's very difficult to find out where and what's happening. The next, we can actually click on these arrows in the diagram or on the call itself, and we can open up and look at the protocol analysis. And we have a choice. We can actually go to links, or we can go to the whole call and dive down and bring the protocol analysis into the window, and we can see a list of all the protocol analysis signaling above, and we can have the different colors of the different protocols involved. And then by clicking on one of these messages, we can see we can fully decode the message, and also we have the hex system available as well. And by clicking another button, we can actually look at a call flow diagram of this particular sequence. So here we can see looking at the different sequence of each link of the call legs, and we get a full description and full call flow of the raw data that occurred on the call. And here we can see the particular problem in full view. So it's a matter of a few seconds to get the search, 2 or 3 clicks, and we're down at the protocol level looking at the problem to solve. Another a benefit of the iCDR is when we're doing transit networks. Here we have operators connected to our network, and we're providing a service to connect those particular networks in one country to another country or to the rest of the world. When we have our particular CDR, it's just one message or one piece of data information fed into a reporting system, and there we see the starting or the originating call and the destination of the call, and we get a lot of very fast and good reporting of service level management without the complication of looking at one particular innet and the other innet and trying to match up the service how it was across the network. We actually provide with an iCDR just how the service was across the network. Another way our iCDRs help the customers, when we're doing mobile content on the user plane, we can see here we have the iCDRs and we put them through the reporting, which is online, and now we get the issues of the websites visited, and some of the you can see on the right hand side there, a lot of these websites today are from Facebook. But an interesting one here is the blue one, the fourth from the top. That's a website giving out the Microsoft updates, and this is the thing that can't be seen using normal CDRs because it's not a customer service, but it's just part of we can see it when we do our monitoring, but it's not a customer service. It's somebody looking at computers, so a computer talking to another computer, sending information. So this is where an operator can say, hey, we don't want updates at a particular time, so he can now vary this update to only be allowed in off-peak times. So he can actually then distribute his load much more evenly for customer services. By then this particular content, we have also CDRs, and we can actually drill down to these CDRs and have a look exactly how these flows occur in the network and what the problems are. In these CDRs, we actually do a lot more correlation of the information coming on the links, and we can, from this information on these CDRs, we have network elements all the way down to the access elements. So here, these CDRs can be drilled down to find particular cell issues. We can put them in reports to have top cells, worst cells. You can actually use these to manage your coverage, manage the rollout of different network, new technology networks, and invest only where you need to. So these CDRs have a lot of information for upstream customers because it's the correlated end-to-end from where it starts in the network to where it finishes the network. The information is all in one iCDR. Another benefit of our particular system is we were talking about the IP network. These iCDRs only have a very small effect on the national WANs. And our customers, when they deploy our particular product, the WAN is very low impacted, and customers like, for instance, Russia, we have end-to-end from Russia, a customer who is using very little bandwidth but has a central monitoring system in Moscow, and he has looked at the whole country with just one central server. So this allows a very effective means of central management, and the other benefit is that the CDRs, when they come from a central management system, the CDR contains the end-to-end customer call. So we can say that when you have a CDR from a centralized management system, it is much more useful and valuable than CDRs coming from various regional computers. So when we look at the central management style of the particular network deployments, we can see here that from a central server we can export these iCDRs into customer experience management system, and there they can be enriched with customer profiling and other demographic information for upstream very simply. The marketing CDR is used using our content CDRs and also our other CDRs, and the marketing department then has the full end-to-end, and they can see a lot more information, and of course they're online. A lot of our customers also have fraud detection systems, and these online correlated CDRs help in fraud detection. There's also another CDR flow that we also produce, and that's an online CDR for a call open, where it goes into the fraud detection system to provide the online call start, and the fraud detection can look at black-white lists and make a decision whether to go ahead with the call or tear it down. So this fraud detection is a very big issue. Next is the billing verification. So we have now a vendor-independent iCDR, and it's only one record. And when we go into a billing verification, then the CDR is already correlated into one record. There's no other correlation required. It goes into billing verification, where it's compared to billing CDRs, and a comparison is made, and you get a very quick response to see what's missing in your billing revenue. You can very quickly pick up switches that have had the billing CDR chain not configured, and therefore the revenue on that particular switch is being lost because it's not connected to the billing system. This can be picked up very quickly. And of course any other third-party systems that can use our CDRs. So we can export with the DEX. The information coming from the applications online in the central server also have alarms, And these go to a TMN platform, and these can be also exported. So the iCDR online correlated data, so we call it an intelligent communication data record. Its main purpose and main benefits are faster detection of service degradation because we're online. We have faster problem detection. Our service revenue losses are minimised, so the system pays for itself very quickly. And we have an easier centralised network management rollout, where we have one CDR for the whole network countrywide end-to-end. So that's the end of my presentation, and I would like to now hand back to Mark, who will close.
Hi guys. Well, we've actually got a few questions that have just come up, so thanks very much for that, Ian. I'm going to put you back on the spot in just a second.
Okay.
Just as we like to do. Just remind you guys, you can also still keep asking questions while Ian is talking now, but we've got a couple of questions for you here, Ian, which I hope you don't mind answering from the off. So I'm just going to bring these up from the guys in the audience. So the first one to get your head around is, within this, you've talked about the customer details in searching the iCDR data. How do you search for particular network elements?
Okay, well, as I mentioned before, we have the CDRs. There are correlated CLRs underneath the CDR, and each CLR is being captured between network elements. So each CLR will have the details of the network element in it, and therefore we can search using what we call point codes, or for IP addresses when we're talking IP network elements. So we just have to enter in a search field. We can say, okay, I want to see a particular customers of a destination, but I want to see a particular network element. So you can drop down easily a particular field and enter in the network element details and identity and say search. And it's very quickly, it comes up with the required information. So that's all in the CDR.
Okie doke. So I've got another one here for you, so maybe just take a quick gulp of the water. How many iCDRs are generally searched in a large network, Ian?
Well, when we talk about networks, I mean, large, it can be different things to different people. Let's start with our particular customer in Europe. It's one of the largest networks, mobile networks in Europe. And there we are searching something like 1.5 billion records. And so we're getting the customer data out within seconds, 10 to 15 seconds of 2 or 3 days of transactions. So this is the sort of type of thing we can do.
Okie doke. Got something else someone's just popped on there just to... so is it practical to use iCDR as a feed for a billing system?
Yes, you can. However, a billing system requires very secure information, and so the deployment would have to be redundant. And therefore, we can do this by making all the particular fail-safe mechanisms where they can have a failure. We have to put in redundancy, and then we roll out and we can make a billing system. What we normally have been asked to do is just making a billing verification system. So the normal billing systems are installed from other operators or other service providers, and we just provide a comparison to the billing system. But yes, we can also be the actual billing system.
Okay. So there's another one here from the member of the audience. So with so much online processing of the captured data, how does this affect system performance and the number of users of the system itself?
Okay, with the captured data, what we've done in our particular design is we've made the dimensioning of the database control and the dimensioning of the application server, and then we also have a dimensioning for the users. So in this way, we have the resources planned for the users who are using the system don't interfere with the processing of the data. So the design of the system is so that the processes are not shared, they're individually allocated to their particular users. And in this way, we have over 200 power users using a system, and it's no effect whatsoever on performance. However, if they all had to do it instantly at the same second, you maybe have this problem then, but I don't think we've ever had that, a complaint yet, so that's no problem.
Okay, and something which leads on from something else from before, which you may have touched on, but someone's just asked, how does this work for data sessions, and what's your definition of a data session in terms of time and data usage, etc.?
A data session for us is on a GPRS or a UMTS packet service, and we are looking at the data sessions coming from the radio access where the base station is into the core network where the SGSN and the GGSN are located for the data. And so we have a control plane monitoring and a user plane monitoring. So in our particular iCDRs, we are monitoring the access and all the attempts of customers coming into the core network. So a data session for us would be the control plane to make performance analysis of the radio access part of the network to see how our customers are accessing our particular core network. And this is important because when we're looking at the user plane is a record of the successful connections and what they are now using. So there's two different things, and we have the control plane CDRs and the user plane CDRs. So this is what we have. A definition of a session for us would be a session connecting a tube or a GTP tube from access to SGSN through to the GGSN, and then the user plane would be from the SGSN to the GGSN to the internet outside. So this is our definitions.
Okay. Well, I can see someone typing away. So any more questions, anybody? I can see somebody typing away, but nothing's coming up. So no. Okay, listen, that's been brilliant this afternoon. So I'd just like to thank Ian Dawson, Senior Marketing Manager from Nexus Telecom, for that, and also Dan Baker, who's founder of the Technology Research Institute. Now, just to let you know, the full webinar will be available about a week from today, and that will be on vanillaplus.com. And should you have any follow-up or any questions or anything like that, you can get in touch with myself, which is MD, Mark Dye, MD at vanillaplus.com, or the editor, George Malin, which is george at vanillaplus.com as well. And obviously the guys would love to hear from you too. So listen, Ian, thanks ever so much for that this afternoon, and Dan, thanks for your time again.
You're welcome.
Thank you.